basically, I'm recording what is on Uber now. So if you want to introduce yourself and kind of give the topic, and if you share that, we'll see. If we pull it off successfully, it'll be our first recorded design forum. So.
Okay, I guess I should start.
Sure.
Good afternoon, everybody. Thank you for coming. So what I will be presenting today is my project of introducing a relationship-based access control for OpenMRS. It's been something I've been working on for a few years. The idea comes from the limitation that role-based access control introduces, where an example is if a doctor is able to view a patient's profile, then they can view every patient's profile, regardless of their relationship with the patient. So relationship-based access control, or ReBAC, tackles this limitation of ReBAC. So if I share my screen.
All right, you can see it.
Okay, so this is fine?
Yes.
Okay, so I just wanted to introduce myself. My name is Zain Rizvi. I'm a master's student at the University of Calgary. This project involved my supervisor, Philip Fong, also from University of Calgary, and Jason Crampton and James Selwood from Royal Holloway University of London. Okay, so the reason we're doing this is because ReBAC in OpenMRS does not protect each resource specifically. So the example I gave was if a user can view a patient's profile, then she can view the profile of all patients, regardless of their relationships to each other. So we do want to base authorization decisions based on relationships between the users and the patients, or the doctors, the patients. And this will allow cases where you can say that only my doctor is allowed to view my patient file, or a doctor who is being referred to, or somebody who's seeing me. So there is some legitimate reason for that person to be able to see my file, not just because they're a doctor in the system. So here's just an abstract of what I'll be talking about. Very brief about OpenMRS architecture, the access control aspect of it, and then introducing relationship-based access control and how it was introduced into OpenMRS. Okay. So as mentioned earlier, OpenMRS uses role-based access control, and the way it protects resources is through service layer methods, which is the API for OpenMRS. When a user from the web application needs to interact with the system, they invoke service layer methods. However, these methods are protected by privileges. But if a user can access a method, then they can request any invocation of that method, meaning they can provide any parameters and be able to get any results back. So it's not really specific as to which resource they're trying to access. That's not being guarded specifically. But when a service layer method is being invoked, it is actually intercepted by the authorization device, where the ReBAC model comes in and checks, does the user have the proper privileges in order to access this method. If the user does, then the service layer method is invoked, and the system operates properly. If the user does not have the correct correct privileges, then the invocation is halted. So the user is not able to access that method. This gives us this kind of structure where we have the web interface on top, what the user interacts with when they try to call service layer methods. They are intercepted with Spring AOP, aspect-oriented programming, the before advice, meaning that it's only intercepted before the method invocation. If the service layer method is allowed to be invoked, then it calls the DAO, which interacts with the database, and the method and the return values are prompted backwards. So introducing relationship-based access control, which tracks relationships in the system and bases authorization decisions on these relationships. not only does it allow for relationships between users in the system, but it also allows relationships between resources in the system. So, relationships between resources and resources, users and users, also between users and resources. So what we actually did was we took the base OpenMRS data class and allowed relationship between any instance of that class. So this covers all our data objects instead of the metadata objects. The system allows for 3 types of relationships. The first one is the original OpenMRS relationship that are part of the patient record. These relationships are between person to person. There are several relationship identifiers or relationship types, as they're called, to allow to distinguish between different types of relationships. So you have something like sibling, parent, uncle, aunt, that sort of thing going forward. And these are directly managed by non-administrative users, meaning that a doctor can go into the patient dashboard and add new relationships or delete existing relationships as long as they have the correct privileges. So these are the original OpenMRS relationships. We introduced a secondary type of relationship, which is very much like the original relationships. We call these access control relationships. And they're similar in the sense that, well, they are a person-to-person relationship. So we have the person object in OpenMRS. So it's between these two type of objects. There are also multiple type relationship types, so different types of identifiers. However, these relationships are not part of the patient dashboard. They're mainly used for access control purposes. So where the patient dashboard may contain relationships such as a sibling, the access control relationships would be something more like a doctor-patient relationship or co-worker type of relationships within the system. And these are not directly managed by users. This is because if users are directly managing these access control relationships, something might go wrong. So example here is if a patient is being moved from one doctor to another, it could be that the new doctor introduces their relationships with the new patient, but does not remove the previous relationship with the previous doctor. So both relationships stay intact. The old doctor is still able to view the patient's profile, even though they're not the practicing doctor anymore. So in order to prevent inconsistencies like these, we introduce objects called actions. These objects allow us to introduce and delete relationships doing multiple things at a time. And what you're seeing here is 2 views of these objects. So the top view on the action is actually an administrative view showing how an admin user creates an action. An action has several, what we see here is 5 parts. The first one being just an identifier, just a name for it. The second aspect here is the enabling precondition. And this is a relationship type that's been defined in the system. And this specifies a precondition that the user who wishes to execute the action and the patient that they wish to execute the action on must share with each other in order for this action to be available to the user. So here, in this one, we have something called the add board nurse. The enabling precondition is that the user and the patient have the family doctor relationship, so that the user is the family doctor of the patient. If that is not the case, the user will not even be able to invoke this action. So the next part we have is the participants. So we are adding and deleting relationships between members in the system, between people objects in the system. So this may be more than just between the doctor and the patient. So we have additional people that might be introduced here. So this is where we introduce how many participants would be involved in this action. Next is the set of preconditions that should be shared between all the participants that are involved in this action. I will go over that just a second. But the last part here is the set of effects that would take place if this action is executed. So here we see the effect one is that we add a relationship between the patient and this participant that we named ward nurse, and the relationship type would be of ward nurse. This would introduce this relationship. And then next to that it says add effects. So we're even allowed to add more effects. So have more than one effect per execution of an action. So this could be you introduce a relationship and then you delete one. Below we see the relationships. Below we see the action being executed by a user who is in fact the family doctor of the patient. So again, we see the name on top. We know that the enabling precondition has been satisfied because this page is able to show up. So in the participant section, the user selects the person that they want to introduce this relationship with. So this is being used by the user finder that is already part of OpenMRS. You start typing a name and it suggests which person you're trying to look for. Instantiate that with a person, and it tells you what the precondition of invoking this action should be. So it says that the participants are related to a ward nurse precondition. These are a set of relationships that have already been defined somewhere else through hybrid logic, and they're just being reused here in this action to define what they are. So as long as the three participants involved in this action can satisfy these relationships, then the effects take place. If these participants cannot satisfy these relationships that are defined by the precondition, then these effects do not take place. And then the last one is it tells you what effect is taking place if you execute this action. An important thing to note here is either all the effects take place or none of them do. This is to keep the consistency of the social network or the graph, the set of relationships intact. Because if you only have an action that is executed partway through, it may lead to misconfigured social network or an authorization graph. The third set of relationships that we have are called the implicitly defined relationships. And again, these are between base OpenMRS data to base OpenMRS data objects. So this could be anywhere between a person to person, or something like a patient program object and a person, or even between those two types. These relationships are based on the state of the system and they don't have to be explicitly created or declared. So the example I'm going to show you here is we created an owner type relationship with objects and patients. So here we have the base OpenMRS data class. At the bottom we see that I've introduced a method called getResourceOwners. So this is an abstract method, which means that every concrete subclass of this class would have to instantiate this. So, and we see here we have the patient program class, and at the bottom this method has been instantiated. So we have the getOwners method where we say that the patient that belongs to this program is the owner of this object, and so we have just a list with this singleton object in there. So just that one patient owner. And the relationship that uses these owners is described here in this class. So here we first check if the relationship that we're looking for, or the vertex we're looking at, the object we're looking at, is it a type of base OpenMRS data object? Because we need to ensure that it has the right methods instantiated. If it's not an instance of base OpenMRS data, then we just return an empty list. However, if it is an instance of base OpenMRS data, we invoke the getResourceOwners method and get the list of owners that belong to that object. and then we just return those. So this allows us to find a relationship based on the state of the system that didn't have to be explicitly declared. Moving into the authorization advice in OpenMRS, so we introduced the ReBAC authorization advice orthogonally to the ReBAC authorization advice, which means that first the ReBAC authorization advice is invoked, and if that allows access, only then is the ReBAC authorization advice invoked. If the ReBAC authorization advice denies access to the service layer method, then the ReBAC authorization advice is not even invoked because the ReBAC didn't allow access. So the thing that's different here is that instead of just having a before advice, we also have an after advice. And that's because the way the ReBAC authorization advice needs to function. And I'll show here. The service layer methods come in two varieties in OpenMRS. So there are the setter methods, which alter the state of the database, meaning that they introduce things to the database or they delete objects to the database. And here we know the target resource is because it's normally within one of the parameters that is part of that's the resource. The parameter that's the resource that somebody might want to save to the database or delete from the database. So here we perform the authorization checking before the method invocation. That's because if the authorization checking is done after the method invocation, well, it's already too late. So we need to make sure that we perform authorization checking before the method is invoked. And it's easy to find the resource because we know it's one of the parameters. That would be one way to find what the target is of this method invocation. However, the getter methods are a bit more difficult to find the resource method invocation because methods like a search method or a get method where you submit some kind of search field like an ID number of an object, that's not really the resource because that's just an ID number. So in this case, we need to do the authorization checking after the method has been invoked, because since the method has been invoked, we know what the resource is. So here is what we did to find what the resources are. We created our annotation called addResource, and for setter type methods, we introduced it within the list of parameters that's given in the interface of the service layer methods. So the parameter that has the addResource annotation attached to it, we know that would be the target resource that we're trying to do ReBAC authorization against. And for the getter methods, we just introduced this beforehand, before the method. This allows us to know that, okay, since the method has an annotation, it means that it is a getter method. And we need to do authorization checking on the return values of the method. However, there are some methods that return a list of resources back. So in this case, we iterate through the list, perform authorization checking on all the objects in the list, and filter the results that are not allowed access to. So if a user tries to search for a list of patients, and he's returned a list, so the service layer method returns a list of patients. Each of those patients has to go through authorization checking between the patient and the user. If they share the correct relationships with each other, then the user is able to see the result at the end. If they do not share the correct relationships, then the patient result gets filtered out. So it could be the case that even though ReBAC allowed access to the service layer method, ReBAC did not allow access to the service layer method, and so a blank list is returned. So the user doesn't really see any results because the result all of them were filtered out. And in order to make authorization checking in ReBAC a bit easier, we introduced authorization principles that behave like roles in ReBAC. So what their purpose is to provide a connection between users and privileges using ReBAC instead of ReBAC. So in contrast to ReBAC roles, where the membership is assigned statically, so for example, you assign the user a role, and that user has that role always until that day that has been revoked from the user. Membership to authorization principles is done between the time of the authorization request. For example, if a user tries to access a resource, then based on the relationship between the user and the resource, the membership to authorization principles might or might not exist. I have an example coming up next. So these relationship predicates or these relationship requirements are provided through hybrid logic formulas. Unfortunately, I'm not an expert in hybrid logic formulas, so I won't be going into detail regarding that. However, there is a paper I can cite at the end of this presentation that shows how hybrid logic works. So the example here is we have a user Alice who wishes to access some resource R, and through some service layer methods which requires the privilege P. So when she's trying to access the method, the authorization principle, call it AP, has a requirement such that the requester is the general practitioner of the owner of the resource. So we have a relationship between three entities. There's a requester, there's the resource, and the owner of the resource. So it would be that Alice would be a member of this authorization principle if and only if she can satisfy this relationship against the resource R. And if the authorization principle offers the correct privileges, meaning the privilege P in this case, then she would be allowed to access the resource. So the example here is, so we have the three entities, the resource R, the owner of the resource, which we name Bob, and then Alice, and the direction arrows show the relationship shape with these three entities. So the owner of R is Bob, and Alice is Bob's general practitioner. Therefore, she would be the member of this authorization principle because they do satisfy their relationship. If the authorization principle offers the correct privileges, then the method would be able to be invoked, and Alice would be able to access the resource R. So the membership in authorization principles is a costly process because it requires accessing database for all these relationships, and the algorithm to do that is a backtracking algorithm. So that is a time-consuming process. So to ease this, we introduce two authorization schemes. So I'm just skipping over to the bottom point here. So the two evaluation scheme is, one is the eager evaluation. This means that when ReBAC authorization is being computed, the algorithm first computes membership to all principles, so to all authorization principles. So this computes for every single authorization principle. It checks if the user is a member of these authorization principles or not. So this is the long way of doing things because it requires computing principal membership for all the principles, and that is a costly process. A second way of doing this is to do a lazy evaluation, where the principal membership is only computed when it's needed. So for instance, that if we know that principal offers the required privileges for the method, that is when we compute the membership for the user between the user ends and the target resource. Okay, so with these two, we also have introduced two authorization semantics. Since we are basing these authorization decisions on relationships, It's a bit unclear, so if we should allow access just based on a single relationship or multiple relationships, because we have the guard in OpenMRS, which sometimes requires more than one privilege in order for the method to be invoked. So for those cases, we can see that privilege one comes from authorization principle one, and privilege two comes from authorization principle two. Is this correct or not? So in some cases it might be okay, in some cases it might not be okay. That's why we have the strict and liberal ground semantics. The strict ground semantics says that all of the required privileges should come from a single authorization principle. But however, this does not interfere with how the ReBAC authorization advice works, because all of the required privileges could come from multiple roles for the ReBAC aspect. But however, for the ReBAC aspect, it must come from a single authorization principle. And in contrast, we have the liberal ground semantics, which doesn't care that how many authorization principles are used in order to provide the required privileges. So this just uses all of the principles that the user can be a member of to see if the guard can be satisfied, the privilege requirement. So moving into our empirical testings, what we did was we wanted to see how fast this works. So we randomly came up with some configurations for the ReBAC part of the system, and this was based on some numbers we've seen online on the discussion forums regarding OpenMRS deployments in various parts. So the number we came up with is that we had 10,000 users, 200 privileges. I know OpenMRS already has a default of 197 privileges, so we just scrubbed that up to 200. We generated 67 roles and 469 privileged role assignment pairs, and the 10,000 users are assigned to 50,000 roles. So on average, a user is assigned to 5 roles. And now to introduce the social network or the authorization graph of relationships, we picked out from a Stanford study, which had quite a big size, because it had 1.6 million vertices and over 30 million edges. So this was a pretty big authorization graph that we tried on. And we had about 8 configurations that we wanted to test. So the first two on the left you see are RO1 and RO-all, meaning these are just role-based access control by itself. RO1 refers to methods that require one privilege or a privilege among a list of privileges. And then RO-all requires a list of privileges. And the next word we saw was for ReBAC, and we came up with 6 configurations here. So we have ReBAC with 1 privilege using eager evaluation or lazy evaluation. Then we have ReBAC with a list of privileges using either eager or lazy evaluation, and either strict or liberal ground semantics. So having these 8 configurations, these are a few of the numbers we saw. So ReBAC by itself is the running time there is negligible, because, well, it's just ReBAC on its own. When ReBAC is introduced, we see an increase in time. So a simple thing here you see is that the eager evaluation scheme, so where we jump people to principal membership for every authorization principle beforehand, is a long process. And but if we use the lazy evaluation, meaning we compute principal membership only when needed, the time is less than 0.05 seconds. So
is that per method?
Yes. Per method. Yes. So what we did was we generated 200 methods, and then we took the average.
Okay. But that would be the time introduced for one method call?
Yes, the time for one method call.
Okay.
On average. So concluding this, so what ReBAC does is it protects each resource specifically based on the relationships between users and resources and patients. The ReBAC authorization checking is orthogonal to ReBAC authorization checking, meaning that first ReBAC authorization checking is invoked. If that allows access, only then the ReBAC authorization check is invoked. And so the only way authorization is allowed is when both authorization systems allow access. That would be the third one here. Just a project summary. So the source code has been posted on GitHub and it's available. When this project started, the source code for the OpenMRS was in version 1.10. So it is a few years old. That was the version I was working with. This does include core changes to OpenMRS source code. So it's not like it's an external module that can be added easily. Just to give how much code was added, was about 25,000, almost 26,000 lines of code added here. There were 113 new files, 26 new database tables, 15 vegetables. Oh, sorry, 15 new web pages, and the demo is. I posted a demo in the OpenMRS talk section, a 5-minute video showing what it does.
Okay, cool.
The two papers related to this are the publication regarding this project. It can be found on my student website for free. It's available there. Also, I posted a version in the OpenMRS talk forum. And then the second paper here is by my supervisor and his colleagues describing a relationship-based access control through hybrid logic. And I believe that is everything. Thank you.
Wow, very cool. I appreciate your sharing it. I'm sorry that we didn't have more of a showing of people here to appreciate it. I did jot down some questions as we were going through.
Sure.
I mean, one of them was around performance, and I think you addressed that. The one question came up was, have you thought about how it would be used in kind of real world scenarios? So, you know, I think of, you know, like people granting access to someone in the theory of, say I'm a doctor and I want to allow a nurse to access. That seems relatively straightforward, but in the day-to-day practice, you know, I come into clinic and maybe my nurse is out sick and there's a new nurse helping out that day. How does he, you know, get patients ready before I've shown up if they don't have access? So did you think, like, one way I could see working around that would be granting authority but based on a role, like maybe a organizational role, you know, to say, okay, well, if you are the nurse for clinic A today, you should be granted access. Have you thought about how this could be applied? Because I was happy to see your kind of implicit relationships and how that could help, but it seems like when you get to granular control, if you have people trying to manage that in real time, definitely patients are unlikely to be granting. In most cases, patients aren't going to be interacting with the system to grant access. So just wondered, you know, have you thought about potential solutions or how this would apply to kind of real world scenarios?
Yes, so it doesn't always have to be a relationship between the patient and the user that is trying to grant, that can be used for granting access. It could also be a relationship between the user and the system. So like you said, if a user has, you know, if somebody is a nurse checked in at the time, so that could be defined through implicit relationships. But you know, you have a user logged in, and yes, they do have some relationship with the system going on. And that can be done through implicit relationships. So think it would need to be carefully assigned, but I do think it is possible using implicit relationships.
Okay. And do you do you think about did you have any thoughts on like breaking the glass? So, something where a patient comes in an emergency situation, I don't have access, but I need to be able to say, you know what, I need to have access because the patient's dying.
So we don't have much of a sophisticated break glass type of structure here, but the relationship-based access control model does come with an off switch.
Okay.
So what you can do, or at least what an admin user can do, is turn off the requirement for relationship-based access control. And so like in case of an emergency, only our role-based access control would be there.
Okay. I guess I could also see, because usually those emergencies are going to happen not organizational-wide, but for a particular patient. But one way might be to say, provide a button or a feature that says, if you press this, I will establish the personal, their personal relationships. I will make you the person's doctor, but I'll also record that for auditing purposes or something like that. So maybe there's other workarounds there. What was it? Oh, I thought of when you filter results. One of the things that has come up with in other discussions around filtering results, like patients having granular access to who gets to see their data, is did you think at all about when results are filtered, should the person making that request, whoever is requesting the data, do they need to know that the results were filtered, or are they filtered silently? I could see kind of potential, use cases or reasons to go either direction.
Yeah, so that is something I actually wanted to do in this case. So in case when results are filtered, notify the user that they were 13 results, however you only see 4. Unfortunately, I wasn't able to design that aspect of it. So in this case, in the current version we have, it won't tell the user that which results were filtered or even how many results were filtered.
Yeah.
Just because of my limitation, I was not able to implement that, but I wanted to. Even my supervisor wanted to implement. Yeah.
Well, it comes with it gets complicated, because if you filter results, let's say you say, I'm not allowed. Well, I guess it comes up with another question. Would you, would this apply to, because it sounds like you could apply it, because you're doing it based on instance of a particular data, you could apply it and say, I don't want anyone to see my HIV test results. Couldn't your ReBAC be used to do that level of filtering, to say these particular data that were collected on me, I don't want anybody except for my primary care doctor to see?
Yeah, so that would be done using relationships between that specific lab result object and could be done with the doctor person, or could be done with the patient, where they need to have a very strict type of relationship in order to access that particular resource. Because
when you let people know that they're not seeing something, then they can also, it has the benefit of you inform people and they don't make a decision. They might take a different action if they know I'm not seeing the full picture. But also someone can use that knowledge that things have been filtered to figure, if I learn that, I can't see your HIV test result, well, I bet I know why. So it gets deliciously complicated as you start to think through the ramifications. Did you think at all about co-ownership? Like in your examples, you talk about the owner of a resource. Is there the possibility of a group of people or anybody with a role being a viable owner of a resource?
So the example I had there was when I was showing the implicit relationship. The owners, I did try to work with a list of owners. Because sometimes, there are more than one owner. So the example I can think of is the relationship object that's part of OpenMRS, is that there are two people involved in that object, so they could both be owners.
Yeah.
However, the issue of co-ownership in access control is something that's beyond my scope.
Yeah.
And it's really hard to make decisions when you have multiple ownerships. So
Yeah.
instead of putting in something that's simple, something like if only allow access if all owners of the resource allow access, or you share a relationship with all owners of the resource, that might lead to some unwanted results. So a common example here is in Facebook, when you have a picture of a group of people, you would say that every person here is the owner of this picture. And two people may share a friend, where one friend might say that allow this person to see my picture, but the other person says don't allow this person to see the picture. So you have some kind of conflicts going on. And you have multiple ownerships. So it's a bit difficult.
Well, but having smart people like you around is how we solve all those problems. So, I can tell you, historically we've long wanted some level of data level. I mean, we in our kind of caveman way, not being experts in authorization models. I've always talked about this as kind of data level access controls, but was excited to see your paper. I want to thank you for sharing your work, not only doing it, but sharing it online and through the different forums. I would love to find a way to get parts of this adopted. I think folks may be concerned about, I think probably the biggest thing will be performance, and the next thing after that will be the pragmatic or real world implications. And one way to, in terms of how will it affect workflows, and will you be, will it take a lot of, minute management of relationship, or access controls to let people do appropriate actions with the data. And I think you can mitigate the latter by starting out small and just saying, hey, let's not try to put access controls on everything. Let's take a few critical things and leverage this capability to say, you know what? Sorry. I think maybe because my laptop is trying to go on air as well. My main point was that I would love to see this work its way into the community. I think we probably would need to kind of strategize of how that could happen. So you did great work, and I appreciate your sharing it with the community. What is this part of completing a PhD or part of a project, and you're going to graduate and go become the president of some country, or is this something that if we are as a community are able to digest it over the next months to the next year or so, something that you would be available as a resource to kind of say, hey, can we think about doing this or that?
Thank you for your compliments. So this is a project that started when I was an undergrad student.
Okay.
So I continued it into my master's program, and I would really love to be, still part of it if the OpenMRS community is interested in this idea. I would love to do as much as I can to help out if possible.
Okay. Well, I mean, I would love to find a path to bring it in. There's a couple, I know, upfront concerns people will have in terms of both the logistics of getting it involved and what effect it will be. I guess the point I was getting to is that if we could focus on the benefits in terms of let's just, instead of trying to add these kinds of controls across the board, to leverage the ability to do relationship access control, but do that, say, maybe there's certain patients that we don't want people looking at their data, or there's, like implementations, if there's particular cases where ReBAC could benefit them, focus just on solving those particular problems up front as a way, kind of as the Trojan horse to start introducing the code into core, if that makes sense.
That would be a great start. This would include some kind of user study. Unfortunately, getting ethics approval at a project for a project like this at the university level is a difficult process, especially dealing with medical.
Oh yeah. Well, I mean, I think what if we can get interest or buy-in, or if implementations see the benefits, or see particular how this could solve a problem, we might find a way to start introducing it into core. And the other concern is that, and I've been struggling with this, is that there are a number of folks in the community that even with the ReBAC get overwhelmed with managing roles. And so there are folks, implementations that will essentially grant, bypass ReBAC, give access to everything, and then try to apply the authorization at the application layer, which drives me crazy, but I think is also partly demonstrates just the real world. You can create a very powerful model, but when you try to apply it to the real world, you have to find compromises where it doesn't slow people down or kind of get in the way of them getting their work done, but benefits their work. So well, I appreciate your sharing. I wish we had more folks of the community to see this. I'm hoping the on-air works, and we'll be able to share it and let people kind of who missed today's design forum to check in. Daniel or Wycliffe, I know you're still on. Do you have any questions or comments for Zain?
Yeah, mine is a simple question. See that this was done in some sort of a book. Was it because it couldn't be accomplished in a module, or was with a module framework, but then?
I'm sorry, I missed part of the question. So you said that the ReBAC authorization, this was done as part of the core.
Yeah, you forked the core at the core platform, and you did all the changes in there. The other option would be to do this as a module. So you chose the path of the platform versus it as a module. Was it because it would not be possible to do it as a module, or something else?
When I first looked into it, I didn't think it would be possible as a module because we need to introduce new authorization checking. And I couldn't find a way how to do that with a module. Also, we needed to introduce ways to store information, so create new database tables, being able to access those tables for introducing objects, or accessing objects or deleting objects, that sort of thing. In my first preliminary testing, I wasn't able to find a way to do this with a module, and that was the reason we went with a core changes. But if this could be done with a module, perhaps you know how to do this with the module. I think this could make something a bit easier then, because changing core OpenMRS, you can just
I think
add.
The doing AOP, adding tables, getting even into the nitty gritty of some of the transactions that are happening are all very viable or doable through a module. I think the tricky part would be those places where you had to, refactor, kind of annotate existing core objects. That gets a little trickier. Like implementing your abstract method. So go ahead, Wycliffe.
I actually had the same question as Daniel, but he already answered that. Yeah, but I think most of the things that I saw from the presentation, I think you can do pretty much most from the module. I don't know if you ever tried to reach out to the community, to get some help about, like doing some of these things from the module. But most of them I see you could have done them from the module, except what probably Bob said, the one of introducing annotations. Yeah, besides that, you could have done pretty much most of them in a module.
Yeah.
Yeah, I think that was probably because I was an undergrad student back then. I didn't want to bother the developer community that much. I tried taking it on my own, and I wasn't able to find the right answers. That would have been, I guess that would have been my mistake then.
Well, I think you've shown. I think we've long wanted this kind of data level access. You've shown the possibility of it, and I think getting that in front of people, showing them demonstrating how it can work, another potential approach to getting it used by the community. I think I was suggesting finding where it could benefit people and focusing on the small bits that are really important to implementations. But I think what Daniel and Wycliffe are pointing out is another potential would be to say, even if we could only do kind of a small portion of ReBAC, but we could maybe get it to work for a couple of the key cases, like just being able to control access to observations, or maybe just a few resources. If we could the trick would be finding out how to apply that to or resources like an observer or encounter. But if we could pull that off through a module, even just to give people a taste of it, that could also be another way to get adoption, get people seeing the benefit of it and asking for more.
Yep, sounds like a good project for this of 2016.
Yeah. Do you have any interest in being a GSOC mentor next year?
Well, next year I'm starting my PhD, so.
That means you'll have plenty of free time, isn't it? It's a 6-year program, right?
The other thing.
Go ahead, Daniel.
The other question: how easy would it to create a pull request, or just a couple of pull requests, just for the sake of reviewing and seeing potential to put some of the things in the module and to see something? Because I looked at the fork and it wasn't easy for me to actually think this particular deal is and all that. Do you think that's something that you can easily come up with, or somebody else can do?
I think GitHub can let you do like a diff between two branches in different forks, and that's pretty much a pull request.
But would that be different than taking his code, like his fork, and compiling that and just making that easier for people to just try it out?
Yeah. I mean, that's an option. Just take his fork and build that and distribute. Well, use that for people to test out things.
Yeah, I mean, like maybe setting up Zain's fork, compiling that and setting it up on a dev test server, just so people could kind of touch it and see it like a demo server.
Yeah, I think that can work before even you go toward trying to put in the code.
Would you be interested in that, Zain, if we set up like a dev test server, essentially getting your fork running in that, so that people could kind of touch and feel it and see some of the how it functions?
I think that would be really nice. It would be great.
Okay. All right. Well, we can ping the help desk and see if we can make that happen. All right. Well, we've kind of gone over time, although we did start late. Well, hopefully this Hangout on Air thing will have worked, and I'll put a link in the notes page, and probably will be tweeting it out as well. So thank you very much for taking the time. And like I said, more than just this presentation, just putting in the effort, thinking about OpenMRS even as a platform to kind of do your work against. I really appreciate not only your interest, but also your willingness to share. It's only through people sharing like you have that we all end up benefiting and in the end saving more lives. So appreciate your help.
Great presentation. Thank you.
All right.
Yeah, it works. Keep it up, man.
All right. Thank you. Thanks, Zain. We'll see you guys in cyberspace.
Sure, guys.
All right.
Bye.
Bye.